Hola! Oh, my goodness gracious, I don't have to talk so loud. I'm very excited to be here. I'm actually new to NEO as of this January. I'm joining and actually starting an office in the United States in North Carolina. Very excited to be down here. It's my first time in South America. And I must say that the Montevideo NEO folks are fantastic hosts. Thank you so much. It's been a lot of fun. So there's my Twitter handle. You can kind of heckle me on Twitter as we get started. So what is Datomic? How many people, before a week ago, and you looked at the agenda and you saw Introduction to Datomic, had ever heard of it? So a couple of people out of the whole bunch, maybe 2 or 3. So what is it? A new kind of database. Ah! Are you kidding me? A new database? There's SQL and NoSQL and Reac and on, and you want to talk about another kind of database? Yeah, I do. I think it's pretty compelling technology with a lot of really interesting ideas that put together make for what really I think could be a game changer in the database field. If I can give you just a taste of the excitement that we had, I actually worked at a company called Relevance. I don't know if you've heard of Think Relevance. It's out of Durham, North Carolina. They actually wrote Datomic in conjunction with Rich Hickey. And when we were given the presentation about Datomic, we took a whole day. So this is going to be a very dense presentation. I'll try to get you a taste of it. But every 15 or 20 minutes, these are a lot of smart people, architects, great experience. People were saying, wow, this is amazing. Or, of course you would do it this way. Why would you do it any other way? So let's start out. What is a fact? Actually, back up. So I'm going to cover the data model, the transaction model, the storage model, query model. That's kind of the guts of everything. But I'm going to start out here. What is a fact? An event or thing known to have happened or existed. So happened or existed implies time. And that's one thing that not many databases take into account. Datomic's data model, they call datums. And what is a datum? It's the very simplest thing that you can possibly encode as a fact. And it's essentially an entity, an attribute, a value, and time. So here are a few datums. Don, that's me. I love chocolate. And I've loved chocolate for forever. So that was way back in time. And then there's an operation that is associated with datums of whether you're adding it or you're retracting it. And you don't see anywhere in here update. Because guess what? There is no update in place. Datomic adds information to the database, and the whole database is immutable. So why, given that I have time here, would I want to ever get rid of this information? I'm Don Mullen, and my email was don@thinkrelevance.com. So I was added that in the past. At some time, I left a little over a year ago, Relevance. Why would I want to get rid of that information? Why not store that and keep it as a history right in the database? Then further on, I joined NEO. And right now, I really could use some coffee. So those are datums. This should actually be entity, attribute, value, a transaction, and an operation. So we have datums. We need some format to exchange this information. Datomic looked really hard at JSON as a data exchange format, but found it wanting because it wasn't very extensible. They wanted to be able to put type information. With JSON, you need to actually do some string parsing and stuff to figure out what's going over the wire. So they created their own. And it includes basic atomic types, lists, vector sets, maps. I've given you the list, the GitHub link for the format. And there's a Ruby version. And hooks right in, exchanges information with the basic Ruby underlying stuff, maps and vectors. There are also lots of different other languages that it supports, C and Python, etc. So here's a datum in Eden. This is a vector. 42, that was Don. It was converted to an ID for performance. Email, Don Mullen at Neo, 1001 and true for an ad. So what does this do? By defining things in datums, it allows you a lot of flexibility on how you get the information from the database. So traditional SQL databases, very rigid. It's rows and columns. So if you want to work in rows, you just treat datums, you get the datums that share a common entity value. If you want to do analytics on column information, you would grab all the datums that share a common attribute. Let's say you want more of a rich document format. You would traverse based on the attributes, and you can go as far as you want in the document. And the interesting thing here is most document-based databases, they define what the document is when they're going to store it. But Datomic, because it stores everything in this very simple datum format with links, you can get the document that you want at query time. And I don't know about you, but I would much prefer that than having a fixed and rigid format that I'd have to pull out. So it allows a lot of flexibility as you're doing development. And then graphs, traversal of reference attributes. So an attribute actually can be a reference to an entity. So Datomic's transaction model is fully ACID compliant. Now, what is ACID? For those of you who aren't database wonks, so ACID is atomicity. When you put something in the database, it's all or nothing. It either succeeds or it doesn't. Consistency. The database stays valid once the transaction is complete. Isolation. If a bunch of people are concurrently putting transaction in the database, you're ensured that the result of that is as if it went in sequentially. And then durability, if the database crashes, you make sure that the data is actually in there. So how does Datomic succeed in being fully ACID compliant? So this is really interesting. Traditionally, the traditional client server, the database is residing on a big server, it's doing all the work, your processing is there. This was a design way back in the 70s. In the 70s, memory was very expensive. Disk space was very expensive. And so they had to have these trade-offs of having expensive memory and disk space, and therefore create an architecture where everything was happening on the server. Well, today, fast forward to today, you have 1 million times increase in memory and disk space. And we're getting to the point where disk space is almost limitless. You put stuff up in S3 on Amazon, and you can scale that up. So the Datomic team took a look at traditional architectures, and they basically took a sledgehammer to it and broke it apart into pieces. So they're trying to simplify by pulling apart the pieces, and these are the three that they came up with. In order to be ASCII compliant, they took the transactor out and made it a separate piece, running as a separate process. And everything that goes into Datomic goes through that transactor, one at a time. It's just serial. So is that hard to architect? No, it's pretty simple, and because it's so simple, it makes for a pretty robust architecture. The other two parts are storage and the query engine. And the interesting thing here is, we'll talk a little bit about the storage, but the query engine, instead of leaving the query engine on the server, and then you send your queries down to the server, and then get the results back, and all the processing happens there, they pulled the query engine into the application, which is pretty extraordinary because then every application is actually a peer of the database. It's as if the database were local. And it does caching because everything's immutable. It can cache extensively, and you can have a really big box running doing analytics on your production server, caching all the information that it needs, and then putting the information back to the database. So pretty interesting result of splitting out these pieces in the architecture. So I mentioned the storage model. The storage model is treated as a service. So Datomic doesn't provide the actual storage as part of Datomic. It treats it as a service, and it's a la carte. You can have data in memory for quick testing. You can have data on your local disk, which is great for development. Or you can start to scale up SQL Store, Postgres, NoSQL Store, so it supports React and Couchbase, or store a service like Amazon's DynamoDB. So this is really interesting from the perspective of a startup. If I'm a startup and I'm just getting going, I might want to just, get up on Heroku and do a local store, and all that's free with Datomic. And then as I get customers and I start getting some funding, maybe I'll scale up and go to a SQL store or NoSQL store. And then if I'm really great, I got a lot of funding and lots of customers, you can go on to Amazon DynamoDB. So the interesting here is you scale all the way up here. Datomic is fully ASCII compliant. Reads are serial, so there's a gating factor there, but our writes are serial, and reads are elastically scalable, which is really interesting. So it just expands as much as you need. So let's talk about the query model. I mentioned that the query engine is actually in the application in the peer. So Datalog actually has a pretty rigorous academic pedigree. It was created back when SQL, et cetera, were born. It's actually a subset of Prolog. It has pattern matching, the equivalent of relational algebra, plus recursion, so you can recurse through. Has rules similar to SQL views. And it's extensible with predicate and functions. And the interesting there is, as we'll see, the functions actually can be local to the application. Think about that. Traditionally, SQL, the client-server model, when you want to add some kind of transaction or function to run, you have to submit that to the admins. And there's this like, how are you going to get that function? I need this view in there. And sometimes, especially at a big organization, that can take a long time. But those functions, because everything's a peer right in the application, you just have that code. And as I mentioned, Datomic runs Datalog locally in the application. So here's a pattern. Customer ID, email, and email. So there's an entity, attribute, and value. The question mark simply means fill this in. So give me all the customers returning their IDs and their emails. That's pretty straightforward. Joins. The thing here is, instead of having a complex SQL where clause and join tables and having to deal with that, Ruby on Rails handles a lot of that complexity for you, but you still have the rigidity of having the join tables and IDs between these tables. In Datomic, as soon as you repeat a variable name, there's an implicit join. So it's very easy to understand this logic-based programming of what you really want to get from the database instead of having to deal with all the joins traditionally. So rules in Datalog, you can create your own rules. So if I want a product, I want to have all the products that are related if they have a common category. So here, the rule that I'm creating is related product. So every time a product one has a category that is the same, that's true. But we also want to make sure that, like on an e-commerce app, if I want to buy a game, say, or Magic the Gathering, and the e-commerce site, you don't want to say, I think you might want to buy Magic the Gathering. So you have this to prevent that. So this is a really dense slide. I want to take a moment to show. Here, find me all the customer and product combinations where the shipping cost dominates the product costs. So I want customers and products. And here I'm pulling out the address from the customer. And I'm pulling the zip code associated with address. And again, these are all implicit joins that are happening here. You don't have to worry about that. And then I'm pulling the product weight and the product price. But this is the interesting here. This is a function that's running as part of the query. This can be in whatever programming language that you want, and the code is actually stored in the database for you. And then it pulls out as needed, runs that, does the calculation. And the other interesting thing is, because all the querying happens locally in the peer, you can have a long-running query and not affect anyone else. So traditionally, in a client server, you have a view, and it's a little wonky, and it ends up running too long. Who does that affect? It affects everyone. But this is running local, so I can have, this could maybe be a RESTful service or something that I'm calling out to as part of the query. This is really interesting. So the get irony. So most people here are developers, no? How many people are doing development, and as you're writing your application, you change a file and you just overwrite the file? Does anyone do that anymore? No. We use Git. We have, as developers, we have created a set of technology that allows us to look at the history of our code. And isn't it interesting that as developers, we have not given our business customers that capability? Not in an easy way. You can read logs, you can do some data warehousing, but Datomic just has all of that built in. So why do you do source control? The ability to experiment. I want to take a branch and experiment. I want to compare points in time, maybe with a git bisect. I want to reify change. What does reify mean? So when you commit in Git, you're not just committing the change. What else are you committing? Who did it? What time they did it? What ordering did it happen in? So you're putting in change as part of, is an object in the system. And that's what also Datomic does. Each transaction is just an entity in the system, and you can actually query and get a stream of transactions from your other peers and do reactive stuff as the other peers are changing information. Git, you can trigger workflows, you can prove a point. So this is all interesting. And this is how Datomic handles that. Because we're putting time in the database, you can, by default, just get the current state. I want all my customers, I want all my good customers as of right now. Well, with the same identical query, you can say, all I want the customers as of 6 months ago. And it returns the data from 6 months ago. And then you have since, so you have how things have changed. Turns out that the results of every query actually returns the database before, the database after, and the changes that happened as part of the transaction. And you can actually do queries against this information as well. And then you have, this is really interesting. You can do a query as if the database contains some information. So you can do like predictive stuff. It's like, this is fantastic for testing. What if, or even business analysis, what if I made these changes to the database? That database doesn't, that data doesn't go actually into the database, it's local. But it integrates it in as it treats it as if it's already in the database. And then you get the results back. Pretty cool. And then history is just, you can get a whole history and get everything that's ever happened in the database. So, I don't know how we're doing on time. I haven't even been checking. There is a Ruby library for Datomic. It supports both C-Ruby by a REST interface, and it supports JRuby as a full peer. So the peer code actually runs on the JVM. So if you want full peer control, you would want to run a JRuby environment in order to get that full peer capability. That's the link to the diametric source code. Definitely check it out. So, Datomic, an immutable database, really intriguing. I don't know anyone else that's really doing this. It's an accumulation of facts stored as datums. It's fully ASCII compliant, elastically read scalable. So there's certainly some applications that you wouldn't want to use Datomic for. If you're really slamming data into the database, you wouldn't want to use Datomic. But how many database applications really are slamming data into the database? Not many. Let's say 95% don't really need that eventual consistency that some of the NoSQL stuff gives you. Then multiple storage options we talked about, and a logic-based query engine makes for querying so much simpler than especially the SQL world. So I have a couple things I just want to touch on. If this kind of architecture and ideas is intriguing to you, I have some talks that I've given links for, and I'll put the slides up. So Neo is kind of a thought leader in lean and agile. The development of Datomic, not lean. You would not use a lean process to develop Datomic. There's a really interesting talk that Rich Hickey gave called Hammock-Driven Development, worth checking out. It's really about stepping away from the keyboard sometimes. Sometimes really hard problems, you don't want to be banging away and doing TDD and getting all the code in. You want to step back, think about the architecture. Very interesting talk. The value of values is another interesting talk, talking about the power of treating as much as possible everything as an immutable value. And then finally, if there's one talk that you'd never look at Datomic, you're not really interested in it, you're not interested in databases, watch this talk. Simple made easy. Taking something really complicated and making it easy is hard, really hard. And Rich has some really interesting ideas on how to make it easier to be simple. So that's it. I'm Don Mullen from Neo. I'm happy to take questions.